Hey, what's up everybody? My name is Moss and welcome to this tutorial series on GitLab. So for the first topic of this video, we are going to be answering the question, what is GitLab? And then I'll walk you through the basics of Git. What is GitLab? GitLab is an open source software development platform. And at its core, it is a source code management system. But it also offers additional functionality like CICD on top of being a source code management system. And as you can see on the right, GitLab describes itself as a DevOps platform. So what's the difference between Git and GitLab? Git is a version control system. You use Git to keep track of changes made to source code files in a codebase. In contrast, GitLab is a source code management system. So you would use GitLab to host Git repositories so that they can be shared with other people on your team. Similar to how you might upload and share files to Dropbox or Google Drive, you're doing the same with GitLab but for source code. So why use GitLab? GitLab enables collaboration among software teams with the GitLab flow. GitLab also has built-in CI/CD functionality. GitLab is highly interoperable and it can integrate with other tools. These are just some of the features that GitLab offers, but there are a plethora of other features. Now that we have a high-level understanding of what GitLab is, let's dive into our next topic. Okay, let's get ourselves up to speed with some basic Git commands. This might be a refresher if you're already familiar with Git, but if you're not, let's go ahead and verify that you have Git installed on your machine. I currently have my terminal open, and to verify my installation of Git, I'm going to invoke Git, and I'm going to pass in the -- version option, and this will return the version of Git that is installed on my machine if it's installed. And as you can see, I have Git version 2.33.0 installed. So the first Git command that we should cover is the git init command. And if you don't pass any parameters to the git init command, it will initialize the current directory as a Git repository. So if I were to execute the git init command as it is right now, it would initialize the lambda test folder as a new Git repository. And it makes sense to use git init like that if you have a pre-existing code base that you want to check into version control and initialize as a new Git repository. However, if you didn't have a pre-existing code base that you wanted to initialize as a Git repository, then what you would do is you would pass the desired name of the Git repository that you want to initialize as an argument to the git init command. And that's the option that we're going to use. And let's call our Git repository test-project. Okay, and what this is going to do is it will create a subdirectory under the lambda test directory, and that directory will be called test-project, and that will be our Git repository. So I'm going to go ahead and execute the git init command. And you can see at the bottom here, it says initialize empty Git repository, and then it specifies the path of the Git repository. And then directly above that, it gives us an informational message about the name of the default branch in our Git repositories. And it gives us a couple of commands to rename the default branch in our repositories. So let's go ahead and do that. Let's execute the first command here, which is git config -- global init.default branch. And then let's set the default name to the default branch of our Git repositories as main. And then to execute the second command, we need to change directories into the Git repository that we just created. So I'll go ahead and cd into the test project directory. And then to rename the branch of our current Git repository to main, we will execute git branch -m and then the target name, which is main. So if we take a look at the test project directory, it should be empty. Let me clear the terminal real quick. And if I do an ls, there's nothing in the test project directory. If I do an ls-al to see the hidden folders in the directory, you'll see a hidden folder called .git. And the .git directory is what makes the test project directory a Git repository. Without the .git directory, the test project folder is just a folder. It is not a Git repository. It's not tracking changes to any of the files within the test project folder. So if I wanted to verify that the test project directory is a Git repository, I can look for the .git folder, and I can also do a git status inside of the directory, and this will also tell me whether or not I'm in a Git repository. And as you can see from the output of the git status command, we are currently on branch main, which is the default branch that was created when we use the git init command. And then it says that there are no commits yet, so we haven't generated any new git commits in this repository. So this repository is essentially a blank slate. It has zero git history yet. And then in the last line of the output, it says that there's nothing to commit. So the git status command essentially tells us what the current state of our Git repository is. So if we've added any new files to the test project directory or changed existing files within the test project directory, when we perform a git status will show all of those changes in the output. Git status is a very useful command, and you'll find yourself running git status very frequently when you're using Git and working inside of a Git repository. Now, this Git repository isn't very useful to us if there aren't any files in the project that we want to version control. So what we can do is add new files to the test project directory and commit those new files on the main branch. But if we do that, then we're not taking advantage of one of Git's most powerful features, which is branching. So what's important to know is that the main branch in a Git repository, and it's not always called the main branch, sometimes it's called the pristine branch or the stable branch, is a branch that is supposed to be code that has no bugs in it. It's supposed to be deployable code that can go to the customer. And because of that, if you're a developer who wants to work on a new feature, working on the main branch is dangerous, because while you're working on that feature, you might commit some changes that cause other parts of the code base to break. And if the main branch breaks, that breaks the code base for everyone, not just for you. So it's really important to understand, as a developer, you should never be committing changes directly to the main branch of your Git repository. So if you're developing a new feature in a Git repository, you always want to make sure that you're not developing that feature on the main branch. You should be developing it on its own dedicated branch. And you can think of a branch in Git as an entirely separate copy of the code base. It's a copy of the code base that you can work on and experiment in and develop your feature in without having any impact on the main branch of the code base. So you would develop your feature in this branch or this copy of the code base, and once you've completed your feature and you're confident, you've ran tests on the feature and you're confident it can be merged into the primary version of the code base, you can actually use Git to merge your branch and your feature into the main version of the code base. So we are going to follow the best practice of creating a branch in order to make changes in our repository. But before we can actually create a branch, we do have to generate some history. So right now in our Git repository, we have no commits made in the repository. So we have to make at least one commit in the repository so that we can create a new branch and use that branch to develop a feature. So what I'm going to do is create a new file in this Git repository. And I'm going to create it using Vim. So I'm going to invoke Vim, and feel free to use a different editor if you prefer a different editor. But I'll call the file hello.txt. Okay, and inside of this file, we'll simply say hello. Okay. So if I do an ls, you can see that we now have the hello text file in our Git repository. And how does adding the hello.txt file change the state of our Git repository? Well, we can check the state of our repository using the git status command. So I'm going to do git status. And you can see now we have a little bit different output in the git status command. It says that we're on branch main. There have been no commits made to this repository. And then there is one untracked file, and that is the hello.txt file. And Git is really useful in that it suggests commands to use to progress through the workflow. And it says use git add and then the file name to include in what will be committed. So what is the git add command, and what does it mean to add a file to a Git repository? And to answer that question, I'm going to pull up the Git documentation in my browser, and I'm already at the target page, and just for reference, I'm at git-scm.com. So in Git, there is a concept of a two-stage commit. And what that means is that in order to commit changes to Git repository's history, which means make a commit object. A commit object is what tracks a particular set of changes to a Git repository. We have to use this two-stage commit, and this two-stage commit process. And it begins with adding changes from what's called the working directory into the staging area. And if you're wondering, well, how do I know whether or not my changes are in the working directory or if they're in the staging area? It's pretty easy to check where your change is at using the git status command. If I take a look back at my terminal, from the git status output, we can tell whether or not a change is in the working directory or if it's in the staging area. If it's in the working directory, those changes will show up in red as they do here. So this change is currently in the working directory, and we want to move it to the staging area. And what the staging area allows you to do is commit changes that are logically related to each other. So in the working directory, you can make changes to whatever files, and you can make unrelated changes within files. But you don't have to commit all of those changes at once. What you can do is you can stage those changes, the changes that are logically related to each other, before actually creating a commit object. And creating well-formed commits is actually very important to do. So in order to move changes from the working directory to the staging area, we have to use the git add command, followed by the argument of the git add command are the name of the files or the directories that we want to add to the staging area. And then from the staging area, in order to create a commit object, we would use the git commit command. So let's go back to our terminal and add our hello.txt file to the staging area. So to do that, I'm going to say git add hello.txt. Okay, and it doesn't provide any output from that command. But it did execute successfully, and we can confirm that by running the git status command again. So now our hello.txt file is in the staging area. And how do we know it's in the staging area? Well, any changes that are currently staged will show up in green. And you can see here that Git recognizes that it's a new file that has just been added to the repository. And in order to commit this file to Git's history, we would use the git commit command. And we can also unstage this file as well and move it back to the working directory. And Git tells us how to do that. We can use git rm-cache and then the file name to unstage this file. But we won't unstage this file. We are going to follow through with the two-stage commit process. And to do so, we will invoke git commit. Okay, and if we invoke git commit by itself, what it will do is it will bring up the default Git editor and prompt us for a commit message. And a Git commit message is essentially a description, a very concise description of the change that we're making. So it's metadata on the changes that we're making to the Git repository, so that later on, if someone wants to review the changes made to the repository, they have concise summaries of all of the changes that have been made within a single commit. So we can use git commit without any arguments or options, and if so, it'll invoke your default editor. And in my case, it should pull up Vim, and it does, and it prompts me to enter a commit message. But the other option, without pulling up the default editor, so if I exit Vim and do git commit, I can use the -m option, and this way I can actually pass my commit message in line with the invocation of the git commit command. So if I wrap it in quotes, I can then pass in my commit message directly at the command line. And this is the option that I'm going to use, and in my commit message I'm simply going to say adding hello.txt, okay, and end quotes, and then I hit enter. And in my case, it does give me a confirmation message that a commit object was created. But if this is the first time that you're using this Git installation on your machine, then when you invoke the git commit command, it will probably ask you to enter a username and email address for your Git configuration, so that when it creates the commit object, the metadata related to who committed those changes and who was the author of those changes will show up with your information. In my case, I already have those configurations set, but if you want to set those configurations now, you would simply say git config and pass in the -- global option, and then we'll say user.name, and then you can pass in your name. So in my case, I would just say Moss, and then we can also say git config -- global user.email, and then you would pass in your email, same as the username. I won't reset my email since I have it already configured, so I'm going to do a Control-C. And now that we have a commit generated in the repository, we might want to review the history of the repository at a later date. So how would we do that? How would we take a look at the commit that we just created? Well, to do that, we can use the git log command. So if I invoke git log just like this, it will show a list of all of the commits that have been made in the Git repository. So I'm going to go ahead and hit enter. And in the output of the git log command, we can see all of the metadata related to a commit. So in our case, we only have a single commit. And on the first line here, you can see the hash of the commit object. And the hash is the unique identifier of that commit object. And directly next to the hash of the commit is this head and then the arrow pointing to main. What this is saying is that the main branch is pointing to this commit. So essentially the main branch is up to date with the latest version of the repository. And then head and the arrow here pointing to main, this simply means that we're currently checked out to the main branch. If we made changes to the repository, if we made new commits on the repository, it would be associated with the main branch. And then below that line, we have information on the author, and this is information that would have been configured using these commands. So I have the author name and the author email address, and then below that is the creation date of the commit, okay? And then directly below that is the actual commit message that we provided in line when invoking the git commit command. Okay, so now that we've created our first commit in the Git repository, when I perform a git status, we shouldn't see the no commits message in the output of the git status command. And as you can see, we don't see it. All we see is that we're currently on branch main and that there is nothing to commit, and the working tree is clean, meaning there's no changes in the working directory that could be added to the staging area. Now, if we want to make any additional changes to the Git repository, what we should do first is create a branch so that we can work on those changes on a separate branch that isn't the main branch. So let's say I want to modify the hello.txt file, and I also want to add a new file to the Git repository. So the first thing that I want to do is create a branch, and to create a branch, I can use the git branch command. And then as an argument to the git branch command, I can pass in the name of the desired name of the branch that I want to create. So let's call this branch my-feature, and then I'll hit enter. So that just created the branch, and I can confirm that it created the branch by just invoking git branch without any arguments. And you can see that 2 branches are listed in the output, the main branch and then the my-feature branch. But notice something is that the main branch is highlighted green with this asterisk. And what that means is that we're still working on the main branch. If we were to make any changes right now, add any new files, those changes would be added to the main branch if we were to commit them. So what we need to do is we need to check out to the my-feature branch. So in Git, we call it checking out to a branch. And before we check out to the my-feature branch, let's run git log one time. And you can see in the git log output, now not only is the main branch listed in the output, but also the my-feature branch. And both of the branches are pointing to the same commit right now. But also notice that the head pointer is currently pointing to main, which means that we're working on the main branch, and any changes that we make would be committed to the main branch, and they would not be applied to the my-feature branch. So let's go ahead and check out to the my-feature branch, and to do that we can use git checkout and then the name of the branch that we want to check out to. So I'm going to say git checkout my-feature, and it says in the output that we switch to branch, my-feature. And if I run a git status, you can see that we're currently on branch my-feature and that there is no changes to commit. And also if we run git log again, not much has changed, but notice that the head pointer is now pointing to the my-feature branch, and it's no longer pointing to the main branch, which further confirms that we're checked out to the my-feature branch. And any changes that we make at this point and commits that we create will be associated with the my-feature branch, and they will not be applied to the main branch. So let's add some new changes to our Git repository and practice the 2-stage commit process. So the first change that I'm going to make is to the hello.txt file. So I'm going to open it in Vim, but feel free to use whatever editor you prefer. And I will simply add world, so it'll be hello world, and we'll save it. And I'll do a git status. And you can see in the working directory, Git prompts me, it says changes not staged for commit. And then it shows here, instead of new file, it shows that the hello.txt file was modified. And we can either use git add to add those changes to the staging area, or we can use git restore and then the name of the file to discard the changes. In this case, it would remove the word world from the hello.txt file that we just added if I were to run git restore and then the file name, git restore and then hello.txt. And then for the next change, I'm going to create a new file, and I'm going to call it tests.txt. And I'm going to say unrelated change, and I'll save it. And then I'll do git status again. So the test.txt file is a new file, which means it's going to be listed under untracked files. Git currently is not tracking the test.txt file. In order to track this file, we have to add it to this Git repository's history. And to add it to the history, we have to make a new commit. Now remember that I mentioned that we can stage logically related changes together so that we can create well-formed commits. And it might be the case that the change that I made to the hello.txt file is unrelated to the addition of the test.txt file. So I might want to commit these changes separately. So let's exercise the staging area and commit just the changes made to the hello.txt file, and then we'll create a separate commit for the addition of the test.txt file. So to add the changes made to the hello.txt file to the staging area, I would say git add and then hello.txt. And then if I do a git status, we can see that the changes made to the hello.txt file are now in the staging area. And then when we invoke git commit, it will only commit the changes that have been staged to Git's history. So if I say git commit -m, and then we'll say modifying hello.txt, I'll hit enter. So it created a new commit, and then if I do git status, the change where we added the test.txt file to the repository is still in the working directory. And if I perform a git log, we should see 2 commits in this Git repository's history, and we do. And notice now that the branches are not pointing to the same commit anymore. The main branch is pointing to our first commit in the repository, and the my feature branch is now pointing to the latest commit made in the repository where we're modifying the hello.txt file. So now let's add and commit the test.txt file. So I will say git add test.txt and then git commit -m, and we'll say adding the test.txt file. Okay, so that created a second commit. So now we have 2 commits on the my feature branch. So if we list the files in the test project directory, we can see the hello.txt file and the test.txt file. And if I were to cat the hello.txt file, we can see the contents of the file, and it says hello world. So this is the latest version of the hello.txt file on the my-feature branch. If we were to check out back to the main branch, you'll notice that the directory structure gets updated as well as the hello.txt file. So let's go ahead and check out to the main branch. So I'm going to use git checkout and then main, and it says that we've switched to the main branch, and I'll confirm with git status as well, and it says that we're on the main branch here as well. So if I do an ls, you can see that the test.txt file is no longer listed in the directory because on the main branch, the test.txt file hasn't been created yet. And similarly, if we cat the hello.txt file, you can see that it's the older version of the hello.txt file that doesn't say hello world. So while we made changes on the my-feature branch, the history of the main branch has remained intact. Nothing has changed on the main branch. We've only made changes on a separate branch, which remember we can kind of consider almost like an entirely separate copy of the code base. It's an isolated space where we can make changes and experiment without impacting the main version of the Git repository. But if we're satisfied with the changes that we've made on that branch, then what we can do is we can merge those changes and those commits into the main branch. And to merge a branch in Git, we want to be checked out to the target branch, and then we'll specify the source branch that contains changes that we want to merge. So currently we're checked out to the main branch. If I do a git status, we can see that we're checked out to the main branch, and the main branch is the branch that we want to merge changes into. So now that we're checked out to the main branch, we can use the git merge command to merge the changes from the my-feature branch into the main branch. And the only argument that we need to pass to the git merge command is the name of the source branch, which in our case is the my-feature branch. And real quickly before we execute the command, I want to do a git log, and I'm actually going to pass in the --all option and the --1 line. And --all will show us the history of all branches in the Git repository, and --1 line will give us a nice one-line summary for each commit in the repository. Okay, so there's 3 commits in total, and you can see that the my-feature branch is pointing to this commit, and then the main branch is kind of behind. It's pointing to the first commit that was made in the repository. So when we perform a git log after executing the merge, we should expect to see the main branch pointing to this commit. So let's go ahead and execute the merge. I'm going to say git merge my feature, and it gives us kind of a confirmation message saying that it performed a fast forward merge, and we have a new file, test.txt, and a couple of lines were changed in the hello.txt file. And we can also confirm this by performing an ls, and we can see that the test.txt file now exists in the test project directory. And if I cat hello.txt, we can see it's the latest version of hello.txt, which includes hello world. And finally, let's check the history using git log. Actually, I meant to use git log with the one line option and -- all. Okay. So now we can see in the output here that the main branch is pointing to the same commit that the my feature branch is pointing to. So it includes the changes contained in both of these commits. And since the changes that were made on the my-feature branch are now merged into the main branch, there's really no need for the my-feature branch. So I'm going to delete that branch, and I can do so using git branch -d and then my-feature. Now there is one more very useful git command that I'd like to show you. So I'm going to go ahead and clear the terminal. And the command is git stash. The git stash command allows you to experiment with various changes and save those changes without actually committing them to the Git repository's history as a commit. So to show you what I mean, I'm going to make a modification to the hello.txt file. So I'm going to open it up, and I'm going to add a word here. I'm just going to say hello world testing, and I will save the file. So I'm going to run git status, and we can see in the output that the hello.txt file has been modified, and we can stage that change to be committed, or we can actually stash that change where we added the word testing to the hello.txt file. When I use the git stash command, I'm taking all of the changes that are in my working directory, and I'm stashing them away in a reserved location that's outside of Git's history. And to stash our changes to the hello.txt file, I can either say git stash or git stash push, and that will stash the changes made to the hello.txt file away. So I hit enter, and it says saved working directory and index state work in progress on the main branch. And if I perform a git status, you'll notice that I have a clean working directory. That change no longer exists in the working directory, and if I cat the hello.txt file, the testing word is not included in the hello.txt file. That change that I made still exists, but it's been stashed away. And to see that change, I can use git stash list, and it will list all of the changes that have been stashed by Git. So I can see my change in the stash at position 0. And if I want to reapply that change to the working directory, I can either use git stash apply, or I can use git stash pop. And there is a difference between these two commands. When I use git stash apply, it will reapply the changes to the working directory. And you can see here that now hello.txt is modified. If I cat hello.txt, I can see the word testing in the file now. But it will not remove this change from the stash. So if I do git stash list again, I can still see that change listed in position 0. The only difference between git stash apply and git stash pop is that git stash pop will actually pop this change off of the stash so that it is no longer listed in the stash. So if I perform a git stash clear, it will clear all of the entries in the stash. I still have my change applied in the working directory. I'll stash this change again, but I'm going to use pop instead of apply. So git stash push, and then git stash list. Okay, and then I'll do git stash pop. Okay, and it shows that the hello.txt file has been modified. And if I do git stash list, you can see that stash entry has been removed. In later videos, we'll explore a few more Git commands, but at this point, you're ready to start working with GitLab. And in the next video, we'll introduce you to some of the major components of the GitLab interface. In this video, we are going to focus on getting you familiar with the GitLab interface. With the overwhelming number of features that GitLab offers, it's easy to get lost in the interface. So we're going to complete some basic tasks so that you feel more comfortable working in GitLab and prepare you for the activities in upcoming videos. First, let's explain some important GitLab terms, starting with group. A group will allow you to manage settings across multiple projects at the same time. A group enables logical categorization of multiple users or GitLab projects. A GitLab group can also provide a cross-project view of things like issues and merge requests. The next important term is project. A GitLab project is essentially a container for a Git repository. Similar to GitHub repositories, there is a one-to-one mapping from a GitLab project to a Git repository. A GitLab project also has built-in CICD functionality. You can also perform issue tracking inside of a GitLab project. In addition, GitLab projects provide collaboration tools like merge requests. These are just some of the features that a GitLab project offers, but they are the features that we will primarily focus on in this series. Another important term to be familiar with are members. Members are GitLab users or groups that have access to a GitLab project. In addition, members are assigned to roles, and these roles include permissions to perform actions on GitLab projects or groups. One of the most important concepts to be familiar with in GitLab are merge requests. A merge request is a request to merge one branch into another. Merge requests provide a space to have a conversation with the team about the changes on a branch. And it is the central place through which changes are reviewed and verified. And finally, we have GitLab issues. A GitLab issue is a way to track work related to a GitLab project. And we can use GitLab issues to report bugs, track tasks, request new features, and much more. Your software development workflow should begin with the creation of an issue. Okay, so the first thing that we want to do is navigate to gitlab.com. And from here, we'll navigate to the login page. So go ahead and log into your GitLab account. And if you don't have a GitLab account already, then you can create one by just coming down here to the Register Now link. And you can follow the steps on this page to create a new GitLab account. And so if that is the case, then just pause the video and create an account, and then we will log into our GitLab account after the account has been created. So I'm going to sign in. And the home page, once we sign in, is like a projects dashboard. It lists all of our GitLab projects, and then we can also see starred projects, which are like favorited projects, and then we can explore other projects on gitlab.com. And from this page, we can also create a new project as well, which we will do shortly. If we take a look at the navigation bar, on the far right, we have our profile, and we can access our GitLab profile from this drop-down menu. We can set a status associated with our profile, and then it allows us to upgrade to a higher tier GitLab subscription. Then we can also edit the profile, and we can view our account preferences, and then we can also sign out from here. And next to our profile menu, we have a support/help menu. And next to the help menu, we also have this to-do list page, which will basically show us a list of items in GitLab that we're that we need to be aware of, like if there's issues assigned to us or merge requests assigned to our account, then those will show up on this page. Next to the to-do list page, we have a merge requests drop-down menu, and this is where we can access merge requests that have been assigned to our account, or merge requests where we have been listed as a reviewer for that merge request. And then we have an issues page where we can query issues across projects based on query parameters, and the default query here is where my account is the assignee on the issue, but we could have any other query parameter in here, like where my account was @mentioned, for instance, in an issue comment. And next to the top level search, we can create new items in GitLab. So some of those items we can create a new project / repository. We can create a new group, and we can create a new snippet, which is like a code snippet. It's just a small snippet of code. It's not a full code base. And then in the left-hand side menu, we can access various dashboards. So for instance, we're in the projects dashboard right now, but we could also access the groups dashboard, or security dashboard, or the environments dashboard, and that will show related information to those features. Now, before we create a new project, I do want to review the account settings of a GitLab account so that you can get familiar with those, and we will update some information inside of the account settings. So from the GitLab profile drop-down menu, we will select Edit Profile, and that will take us to the top level of the account user settings. And then under Chat, we have Access Tokens. So there's a few ways that you can authenticate with your GitLab account. The first way is the most obvious, is where you go to the sign-in page and you enter your username and password. But if you're authenticating via the command line, you'll likely use one of two ways. You'll either authenticate using a personal access token, or you'll authenticate using an SSH key pair. And this page allows you to create new tokens or delete personal access tokens for your account. And when you create a personal access token, similar to how the applications page was set up, you can select scopes for that personal access token, which will define the level of authorization that that token has to your account. So we can give it write permission to repositories, read permission, the ability to interact with the GitLab API. Below notifications are where we can manage SSH keys for our account. And this is the method that we're going to use to authenticate with our account. We won't be using the personal access tokens. We will create an SSH key pair, and then on this page is where we would add the public key of our SSH key pair to this page. So we would create a new public key for our GitLab account so that we can authenticate with it, and our Git client can communicate with our GitLab account. So now that we've gone over the user settings, I would like to prepare our Git client to authenticate with our GitLab account. And remember that I said that we were going to use SSH keys to authenticate with our account. So what we're going to do now is create an SSH key pair and then add the public key of that key pair to our GitLab profile. So I'm going to navigate to my terminal and open up a new terminal session. And in my terminal, I'm going to invoke the SSH keygen command. So that's going to be SSH-keygen. And then we're going to use -t option. And we're going to specify the kind of encryption that we want to use. And we're not going to use RSA. GitLab advises to use this type of encryption and suggests that it's more secure than RSA. So ED25519. And then we will add a comment to this key, and we'll say that it's our GitLab key pair. Okay. And after you've typed that in, go ahead and hit enter. and it prompts us to enter a file name in which to save the key. In this case, we're going to accept the default file name, and notice where this key is being saved. It's being saved in the hidden.ssh folder, and that's going to be the name of our key pair. So the name of the private key and the public key, and only the file extensions will be different between the public key and the private key. So I'm going to hit enter, and then it prompts us to enter a passphrase for the key pair, and I'm going to leave it empty for no passphrase. I'll hit enter again, and then that generated the key pair for us in this directory, in the .ssh directory. Now what we're going to do is add the public key of that key pair that we just generated to our GitLab profile. And to do that, we'll first cat the public key. So I'm going to cat.ssh ed id underscore ed dot pub, okay, for the public key pair, or for the public key rather. And then I'm going to copy the output to my clipboard, and then I'm going to navigate back to the GitLab interface, and we'll navigate to SSH keys, and then I'm going to paste in the key field, I'm going to paste in the value of the public key in the key field. Okay, and then the title is the comment that we added when we generated the key, so GitLab key pair. And we can set an expiration date if we want to. I'm going to leave that blank so that it doesn't have an expiration date. And then I'm going to select add key. So now that we've added that public SSH key to our account, we should be able to authenticate with our GitLab account from the command line. And to verify that we can authenticate, I'll open up the terminal, and then I can invoke my SSH client. I'll use the -T option, and then we're going to say git at gitlab.com. Okay, and I'm using gitlab.com because my account is on gitlab.com. If you're using like a private instance of GitLab, then you would want to specify that private instance URL. Okay, so if I hit enter, it says welcome to GitLab, and then it specifies my username, which means that it did successfully authenticate with my account. Okay, so now that we know our SSH key pair is working, let's navigate back to GitLab, and I want to take a look at the groups dashboard. So from the left-hand side menu, I'm going to select groups, and let's navigate to the Your Groups page. And on the groups dashboard, you can see that I've already created a group called Tech with Moss group. But let's go ahead and create a new group. So up in the top right here, I'm going to select new group, and then I'll select create group, and then I can give the group a name. So feel free to enter whatever name you prefer here. I'm going to say Moss test group. Okay, and then I can specify a unique group URL, and then under the group URL we can specify the visibility level of the group, whether it's private or public. If it's public, then the group can be viewed without any authentication. And then they have some personalization options for this group. So I can specify what my role is, and I'm going to leave it as software developer, but you can see here that they have other roles that you can select. And then it says who will be using this group, and I'm going to specify just me instead of my company or team. But if I do select my company or team, I have this drop down where I can specify what the group will be used for. And then I can also invite members to the group using their email address. So I'm going to select just me, and then I'm going to select create group. And on the group homepage, I can see subgroups and projects that are associated with this group. So a group can have a subgroup, and from this page I can also create new subgroups or new projects that are associated with this group, this Moss test group. And in the left-hand menu of the group, I can access the group information, which will include the group activity, labels, and then members. And from the members page, we can control the membership that people have to this group. So you can see here, there's one member and it's my account, and I am the owner. So my role is the owner for this Moss test group. But I can add additional members using their email address, and then I can specify the role that that member would have when they're added to this group. And below group information, I can select issues. And if I select issues, it will show me all issues that are associated with this group, which there might be issues created in multiple projects. So this view inside of the group will actually show issues across projects. And in the board section, I can also utilize a lightweight agile board. You can see here that has issues that have a status of open will show up here. Issues that have a status of closed will show in this column. And then you can also add additional columns to match your desired issue workflow. And below issues, we can also view merge requests. So if I select merge requests, we would get a view of merge requests that, again, are across projects. So it would be all projects that this group is a member of. So you can add groups as members to GitLab projects, right? So any merge requests that show up here would be across all of the projects that this GitLab group is a member of. And then finally, we have the group settings. And under the group settings, we have general settings where we can control things like the group name, the group ID, the description of the group. We can upload a group avatar, kind of like how we can upload an avatar for our profile. And we can also control the visibility level. We can control permissions and enable large file storage or disable large file storage, and that's Git LFS. We can enable default branch protection, which allows us to protect certain branches so that developers cannot push new commits to specific branches. Under the general settings, we have integrations, and this is where we can set up new integrations with external tools like Atlassian Bamboo for CICD. We could integrate this GitLab group with a Confluence workspace, also with Jira. We can also specify group level CICD. And here we can define group level variables, which can be referenced from within a GitLab CI/CD pipeline. And we can also configure runners, which I won't get into too much detail about right now. I'll leave that for a later video, but essentially, if you're familiar with Jenkins agents, runners are kind of a similar concept. Runners are processes that pick up and execute CI/CD jobs for GitLab. So now that we've explored the interface for groups, let's navigate back to the home page. And from the home page, let's go ahead and create a new project. So I'm going to navigate up to the top right, and I'm going to select New Project. And on this page, we can create a blank project. So we start a project from scratch, or we can create a project from a project template if we've created a project template. And we can also import a project. So if we're migrating our source code from another source code management system like GitHub, we can use this import project feature. And then the last option here, if we want to use GitLab purely like as if we were using it like Jenkins, where it's just performing CI/CD for us, we can still utilize a external source code management system like GitHub, and then we'll just use the CI/CD feature that GitLab offers to facilitate CI/CD for our project. But in our case, we are going to create a blank project. So I'm going to select the Create Blank Project. And then it takes us to a page where we can fill out some details on our project. Now you can use the project name field to provide a name for your project. But if you leave this field blank and you provide a project slug, which will be essentially the URL or part of the URL of the project, then it will automatically fill in the project name field for you. So I'm going to use that option, and I'm going to call the project moss-test-project. Okay, and notice that the project name field automatically gets filled in as I enter the project slug. I can also specify where this project should live by using this drop down. I can specify a group or a specific user. And right now it's under my account, Tech with Moss, so I'm going to leave it under Tech with Moss. And then I can provide a project description if that is applicable. And under the description, I can specify visibility level, so whether or not the project is going to be private or public. And then if it's a public project, the project can be accessed without authentication to GitLab. If the visibility is set to private, then I have to explicitly grant access to each user or to a group by adding them as members to the project. And then the last setting allows us to initialize the repository with a README file, which we would do if we didn't have an existing code base locally that we would want to push up to this GitLab project. And we don't in our case, so I'm going to leave this setting checked. And then I'm going to select Create Project. So here we have the home page of the project, and we can access the commits, the branches, the Git tags that have been created, and then it tells us a little bit of information about the storage that this project is utilizing. And if I exit out of these messages, we can see the actual code base and all of the files in the code base. And right now there's just the README file, but you'll notice that below the directory, the README file is automatically rendered at the bottom of the page. And the README file was also automatically filled out with some resources to help us get started with our project. And above the root directory, we can also see a couple of other things. The first is the branch specifier. So right now we're checked out to the main branch. So the version of the code base that we're viewing here is the version on the main branch. And if we wanted to switch branches and view a different branch, we could just select the drop down and either search for a branch or a Git tag and then check out to that branch. In our case, we don't have any other branches in this repository, so we only have the main branch as the only option. And then next to the branch specifier, we have the option to create new files, upload files. We can also create a new directory. And this is all within the current directory that we're in. And we're in the top level directory right now, but we can also create a new branch, or we can create a new tag, a new Git tag. And another really cool feature is we can use a web IDE to modify the code base in our browser without having to download it locally and modify it in our local IDE. And next to Web IDE, we also have the option to download the source code as a compressed file. And then finally, we can clone the repository using either SSH or HTTPS. And we didn't cover the git clone command in the last video, but we will cover it in an upcoming video. But essentially, cloning means that we are downloading this project as a Git repository to our local machine so that we can make commits to the repository and then push those commits back up to GitLab. So the key difference between cloning and downloading as a compressed file is that if we were to download it as a compressed file, it's not technically a Git repository. So we wouldn't be able to make commits inside of that compressed file after we've extracted the project. And then in the issues section, we can manage and create issues related to this project. And we also have agile boards similar to what we saw in the groups settings page as well. Below the issues section, we have merge requests, And this is where we can manage and view all of the merge requests related to this project. And right now there are none, but we can create a new merge request from this page. I think we can also create a merge request from the home page of the project as well. Under merge requests, we can configure CICD for the project. So we can create new pipelines, and we will explore this feature in later videos. But we can create new GitLab pipelines and pipeline jobs, and then we can set schedules for those pipelines. In the packages and registries section, we can publish software packages to the package registry, and then we can also utilize the container registry to publish Docker images. And in the infrastructure registry, we can publish Terraform modules if we have any Terraform modules. And under analytics is the project wiki. And the wiki is where you could publish documentation related to the project. So for instance, if you had architectural documentation describing the architecture of your application, you could publish it to the project wiki. And a GitLab project can have snippets of code. So you can create a snippet of code, which essentially is a small piece of code. It might not be an entire code base or an entire file from a code base. It could be just a single function from a file that might be useful to others. So maybe you could share that function with others, and you can use snippets to do that. A snippet can be shared with other users. It can be version controlled and downloaded. Now for the project settings, I won't go into too much detail because what you'll notice is that a lot of the settings are similar to group settings, but they are at the project level. So if I go into settings and then general, you'll see very similar fields to the group settings fields with the exception of merge requests. So this is a big one. You can configure various settings related to merge requests in your GitLab project. So for instance, you can specify what kind of merge method you would like merge requests to take. So down here under the merge method, we can specify whether or not we want a merge commit with a semi-linear history, or a fast forward merge. You can also specify the default behavior for squashing commits when merging a merge request. And then you can enable merge checks as well. So for instance, we can enforce that all pipelines must succeed before the merge request can be merged. In the repository section, we can configure various settings related to branches in the GitLab project. So for instance, we can set the default branch of the project, which means that anytime we were to open a new merge request, the target branch would automatically be selected as the default branch. Another important setting are protected branches. It's typically a best practice to protect the main branch or your stable branch or your production branch, since protecting the branch means that only certain people can actually push commits to it. And also you can disable force pushing to that branch, so nobody can override the history of a protected branch. And under the monitoring settings, we can also control settings related to GitLab pages, which is a pretty cool feature. Pages essentially allows you to host a static website off of this GitLab project. So now that we're familiar with the project's features and settings, I'd like us to go ahead and create a new issue in this project. So I'm going to select the Issues section. And in the Issues section, I'm going to scroll down and I'm going to select New Issue. So for the title of the issue, I'm going to say modify the project README. And for the issue type, I'm going to leave it as issue. But if we select this drop-down, we can also select a different issue type. In this case, we have the incident issue type as well. In the description of the issue, I'm going to say modify the project README file to practice the GitLab flow. And what's cool about the description field is that we can utilize markdown syntax in this field, and then we can preview that syntax in the preview field. So right now we're not using any markdown, but I can modify this and I'll add a hashtag, and a single hashtag will give me a header. So if I preview that, I now have a markdown header. I'm going to change this hashtag to a bullet, and then I'll scroll down and I'll leave the remaining fields empty, but we can assign the issue to a specific user in the project. Right now I'm the only user in the project. We can also add a due date for the issue, and we can associate it with a milestone in the project, and we can also add labels to the issue as well. And now I'll select Create Issue. So now that we have the issue created, you may remember at the beginning of the video when I was discussing the definition of issues, I mentioned that your software development workflow should always begin with the creation of an issue. And in the upcoming videos, I'm going to introduce you to the GitLab flow, which is the primary workflow that you would utilize in GitLab. And we're going to practice the GitLab flow by modifying the README file. Hey, what's up everybody? My name is Moss, and welcome back to this tutorial series on GitLab. After watching the previous video, you should be comfortable navigating the GitLab interface. And this means we can start practicing our development workflow inside of GitLab. To do this, I'm going to introduce you to GitLab's primary branching strategy. So if you haven't already, go ahead and grab a coffee and let's get started. In this video, I'm going to introduce you to the GitLab flow. What is a branching strategy? A branching strategy is a software development workflow within the context of Git or another version control system. And it describes how a development team will create, collaborate on, and merge branches of source code in a code base. We practiced a very basic branching strategy in the first video using a feature branch. A branching strategy takes advantage of the branching system in a version control system to enable concurrent development in the code base. But how do you choose a branching strategy? Unfortunately, this is not a straightforward question, as it depends on multiple factors. These factors include, but are not limited to, team requirements, the source code management system that you're using, the environments to which code is deployed and how you want to manage deployment to those environments, and the structure of your code base. Some of the most common branching strategies in Git include the following: the GitHub flow, the Git flow, and the GitLab flow. Let's take a look at each of these branching strategies. We'll start with the GitHub flow. The GitHub flow is the simplest workflow of the three. Each of the white circles in the graph represent Git commits. The GitHub flow begins by creating a feature branch off of the main branch. While checked out to the feature branch, we would make some number of changes until we feel like our feature is ready to be reviewed by others and undergo automated testing. We would then upload our changes to GitHub by using the git push command. This action is commonly known as pushing our commits. After pushing our changes, we would open what's known as a pull request. A pull request is the equivalent of a merge request in GitLab. The opening of the pull request should trigger automated testing of the changes located on the feature branch. Once the changes have been reviewed and verified, the feature branch is merged into the main branch. Now let's take a look at the Git flow. The Git flow is the most complex of the three workflows. The Git flow utilizes a long-lived develop branch as the default branch from which developers create feature branches. The Git flow also utilizes release branches, which are created off of the develop branch. If a bug is found during testing on the release branch, a bug fix can be applied to the release branch and then merged back into the develop branch. Release branches are then merged into the main branch, and main is tagged with the release version using a git tag. In a perfect world, the changes merged from the release branch into the main branch are bug-free. Since it is unrealistic to expect that this is the case every time a release branch is merged, the Git flow includes hotfix branches. The hotfix branch is created directly off of the main branch to quickly address issues introduced by the changes that are now in production. In addition to merging the hotfix branch back into the main branch, it is also very important to merge the hotfix branch into the develop branch to ensure that any new development work incorporates the hotfix. Now let's explore the GitLab flow and its variations. The GitLab flow is simpler than the Git flow, but more structured than the GitHub flow. There are two variations of the GitLab flow. The first, as seen here, utilizes environment branches. In this workflow, we have a long-lived production branch, which represents the production environment in which the software application is deployed. The code on the production branch should always be deployable. Like the GitHub flow, this workflow utilizes feature branches off of the main branch, but main is merged into some number of environment branches and then to the production branch. You can think of merging a feature branch into the main branch as deploying your changes to a staging environment. Once changes have been verified in the staging environment, they can be promoted to the production branch. You can have multiple pre-production environment branches representing various environments in which the changes must be tested in before merging those changes into the production branch. Unlike the Git flow, the GitLab flow has an upstream first policy when it comes to hotfixes. This means that if issues are found in the production environment after a change has been deployed, the hotfix branch must be created off of the main branch and merged back into main and any other pre-production branches before being merged into the production branch. The feature branching workflow is similar to the GitHub flow, but instead of creating a pull request, we create a merge request. Like the GitHub flow, the opening of a merge request should trigger automated testing. The second variation of the GitLab flow utilizes release branches instead of environment branches. You should use this variation of the workflow only if you're releasing software to the outside world. For instance, if you were developing an open source project. This variation is similar to the first in that you branch off of the main branch into feature branches and then merge back into main. In this workflow, you will want to wait as long as possible to create a release branch. After creating the release branch, apply only major bug fixes to the release branch, incrementing the versioning as needed. Bug fixes are merged with the upstream first policy. Release branches are long-lived until a specific release of software is no longer supported or maintained by the development team. Let's quickly recap the GitLab flow. There are two variations of the GitLab flow. The first variation utilizes long-lived environment branches. In this workflow, changes are promoted through one or more pre-production branches before being merged into the production branch. The second variation utilizes release branches. This variation should only be used when releasing software to the outside world, such as an open source project. The GitLab flow is simpler than the Git flow. However, the GitLab flow provides more structure than the GitHub flow. In the next video, we will practice the GitLab flow in our GitLab account. Hey, what's up everybody? My name is Moss, and welcome back to this tutorial series on GitLab. In the last video, I introduced you to the concept of the GitLab flow. And in this video, we are going to apply the GitLab flow to the project that we previously created. I talked about two variations of the GitLab flow in the last video. And in this demonstration, we're going to be utilizing the environment branches variation. Okay, so I'm on the home page of my GitLab account. And if you haven't already, go ahead and sign into your GitLab account. And once you've done that, we're going to navigate to the GitLab project that we created in a prior video. When I created that project, I called mine Moss Test Project. And I'm gonna open that project up. Now you might remember from the previous video when we created this project, after creating the project we also created an issue within the project, and let's navigate back to that issue. It's under the issues section and then list, and then we only have this single issue in the project called modify the project readme. So let's open that issue up. I mentioned earlier that the GitLab flow should begin with the creation of an issue. An issue helps define the scope of work that needs to be completed. And the scope of this issue is not well defined right now. It just says modify the project readme without any additional information to specify what should be modified in the readme or how it should be modified. So let's edit this issue and update it to be more specific on what updates should be made to the project readme file. So to edit, I'll select the pencil And I'm going to use some markdown syntax that we haven't seen yet. So if you want to create a checkbox that you can check with markdown, you can use hyphen, open bracket, space, close bracket, and then text. So temporarily I'll just put hi. And then if I preview, I can see that next to hi is rendered a checkbox that I can select. Now I can't select it right now because I haven't saved the changes, but you can use this in issues to create like tasks that you can check off within the issue. And for this task, I'm going to say that we should introduce ourselves in the project README. And I'll select Save Changes. And GitLab recognizes these checkboxes as subtasks within the issue. And to confirm that, you can see up here, it says 0 of 1 task completed. And the single subtask that we have in this issue is just to introduce ourselves in Project README. So GitLab will actually track how many subtasks have been completed within an issue using these markdown checkboxes. Now, since I'll be working on this issue, I'm going to assign it to myself. And I can just go up here, select edit, and then I can search for a user, but I'm the only user in this project, so I'm going to select myself. And now that we've further defined the issue, let's navigate back to the project homepage. And from the homepage, we're going to create a new branch. And remember at the beginning of the video, I said that we're going to be using the environment branches variation of the GitLab flow. So to create a new branch, I'm going to come down to this drop down here, and I'm going to select New Branch. And this branch is being created from the main branch, and we will call it Production. Okay, so this will represent pushing changes to this branch will represent pushing changes to the production environment for our code base. Even though this isn't really a code base right now, it's just the README file. So I'll select Create Branch. And you'll notice that after creating the branch, we're automatically checked out to the production branch, or the branch that we created. So I'm going to switch back to the main branch. Let's take a look at the branches that we have in the repository now. So I'm going to navigate to this subsection here, branches. And we have 2 active branches. We have the main branch, which is listed as the default branch, and the production branch. In addition to being the default branch, the main branch is also protected, which means that only people in the project with certain permissions can push changes to that branch. And since we're utilizing the environment branches variation of the GitLab flow, I think it's a good idea to also protect the production branch, since that represents our production environment. And I don't think people should be able to push changes to the production branch unless they are a specific role in the project. And as it says up here, we can control protected branches in the project settings. So I'm going to click on that and navigate to the project settings. And then I'll scroll down to the protected branches section, and we'll expand that. And it says by default, protected branches restrict who can modify the branch. So under the branch selection, I'm going to select the production branch, and then we'll select who is allowed to merge into the production branch, and we'll say only people with the maintainer's role can merge into the production branch. And we'll also set the same for people who are allowed to push to the production branch. Only maintainers can do so. And the last setting lets us allow or disable force pushing to this branch. And it is a best practice to not enable force pushing on shared branches. The only time it might be okay to force push is if you're on an isolated branch and you know that you're the only person working on that branch. So now let's click Protect. And now that branch is a protected branch. Should be listed under here. Yep. we can see it listed along with the main branch as a protected branch. So let's navigate back to the project homepage. Although we can modify the README file in GitLab, what we're going to do is modify it locally on our machine. So we have to get the project onto our machine, and to do that we have to clone the project. So even though it's called a project, behind the scenes it is a Git repository. And when you want to begin working on a Git repository locally on your machine, you have to clone the repository, which will essentially download the code base to your local machine so that you can work on it. And we can clone a repository by copying the clone command specified in this dropdown. And we have two selections or two options. We can clone with SSH or we can clone with HTTPS. And if you remember from an earlier video, we set up SSH keys for our GitLab account. So we won't be using the clone with HTTPS method. We'll be using the clone with SSH method instead. So I'm going to select this copy URL button. And now that it's copied to my clipboard, I'm going to open up my terminal. And in my terminal, I'm going to paste the command, or rather the SSH URL of the repository or of the GitLab project. And then I'm going to preface it with the command git clone. So the git clone command is what we use to copy a Git repository from the remote source down to our local machine. Okay, so after git clone, we just specify the remote repository. So I'm going to hit enter. Okay, and it looks like it successfully downloaded the project, and it created a directory called Moss Test Project. So if I do an ls, I have Moss Test Project, and if I cd into it and I list all of the files, I have the .git folder, so that tells us that we are inside of a Git repository, and we have the single README file that's in the repository. If I do a git status, I'm checked out to the main branch. The reason I'm checked out to the main branch after cloning is because it's the default branch. So whatever the default branch is, when you clone that Git repository, you will be checked out to that branch. So to begin the GitLab flow, I have to branch off of the main branch into a feature branch. So that's what I'm going to do now. And I'm going to use the git checkout command. To create a branch, I can use git branch to create the branch, or I can use git checkout with the -b option, which will create the branch and check me out to that branch in one command. And we'll call the branch readme -introduction. Okay. And you can see in the output it says switch to a new branch readme-introduction. And if I do a git status, I can see that I'm on the readme-introduction branch. And now that we're on a feature branch, we can begin making modifications to the code base. And in this case, we're not modifying code, we're just modifying the README file. And to modify the README file, I'm going to open it up in Vim, but feel free to use whatever editor you prefer to modify the file in. So I'll say Vim and then README. And under the first header, I'm going to put a subheader. Okay, so a markdown subheader using 2 hashtags, and I'm going to call it introduction. And under the introduction section, feel free to put whatever you like. For me, I'm going to put my name. So I'm going to say name, Moss, and then activities I like to do. And I like to mountain bike and play tennis. Okay. And I'm going to put a new line between the subsection and the bulleted list. Okay, so now let's save and quit the file. Okay. And I'm going to do a git status. And we can see our modifications are currently in the working directory for the README file. And I'm going to add and commit the changes to the README file. So I'm going to say git add README. Okay, so now the changes are staged, and let's commit the changes. So I'm going to say git commit -m so that I can pass in the commit message directly at the command line. I'm going to say updating project README with introduction. Okay. So now in our local copy of the repository, we have created a new feature branch, and we made a change and committed that change on the feature branch. But neither the branch or the change that we made on that branch is currently represented in the remote repository. So if we were to navigate to GitLab and I refresh the page, we're not going to see the branch that we just created or the changes that we just made to the repository. And that's because Git is a distributed version control system, and we have to sync changes from our local repository to the remote repository. So if we're syncing changes from our local repository to the remote repository, we have to push our changes, and we would use the git push command to do so. However, if we're syncing changes in the opposite direction from the remote repository to our local repository, then we pull changes, and we do that using the git pull command. Now, right now, there's no changes from the remote repository that are not in our local repository, so we don't have to do a git pull. But there are changes locally that we should push up to the remote repository. So we're going to use the git push command. And since this branch doesn't exist yet on the remote repository, the readme-introduction branch, we have to pass in the -u option and specify the name of the remote, which by default is going to be origin. And after we specify the name of the remote, and origin is is a variable that's resolving to GitLab. Essentially, it's resolving to the URL of the GitLab project. After we've specified the name of the remote, we specify the branch name. So we're going to say origin and then readme-introduction. Okay, so we're pushing our changes, the commits that we made from our local branch up to GitLab, and we're also passing in the -u option to tell GitLab to create the readme-introduction branch. So I'm going to hit enter. Okay, and in the return message, it does confirm that the changes were pushed up, and then it also tells me that I can create a merge request from the branch that was just created in GitLab. And you can see down here as well that it specifies that there is a new branch. Okay, so let's navigate back to GitLab and confirm that. So I'll refresh the page, and you can see in the top message here, it says you pushed the readme-introduction branch, and in the drop-down list, we can now see that branch as well. And if I were to switch to the readme-introduction branch, we should be able to see the changes in the README file. And you can see under the project name, we have the introduction section and the bulleted list with my name and the activities that I like to do. Okay, so the changes were pushed up successfully, and from here we can actually create a merge request, and it suggests creating a merge request here as well. So I'm going to go ahead and select create merge request. And on the merge request creation page, you can see in the title is automatically generated from the latest commit message on the README introduction branch. So if I open the terminal, you can see where I entered git commit. That was my commit message. Okay, and I'm going to leave the title as is. The other thing to notice is the branch that we're merging into. It says from readme-introduction into main. So why is the main branch chosen as the branch that we're merging into? It's the default branch. So not only does that mean when we clone the repository that will automatically be checked out to the main branch, but also when we open new merge requests, we'll automatically be merging our feature branch into the default branch, which in this case is the main branch. And this also follows the guidelines of the GitLab flow as well. The feature branches are supposed to be created off of the main branch and then promoted to main and then to some number of pre-production branches before being merged into the production branch. And in the description of the merge request, I'll be a little bit more descriptive about the change. I'm going to say that updated the README to include my name and activities that I like to do. Okay. Now, if we take a look at the fields below the description field, we have an assignee field, and I'm going to assign this merge request to myself. And then we have a reviewer field, and in this case, I can only assign myself as a reviewer, but ideally you would always want a second pair of eyes to review the code changes that you're submitting in a merge request. But in this case, I am going to select myself as the reviewer as well. And then we can specify the milestone, if there is a milestone associated with this merge request. And we can also add one or more labels, project labels, to this merge request as well. So this is labels are used as a way of kind of categorizing changes. So for instance, maybe if this merge request was changing the UI of our application, we would have like a UI project label that we could add to this merge request as kind of a tag that is searchable if someone were to search merge requests in this GitLab project. And then the last two options are merge options. And the first of which is automatically selected, which is delete the source branch when the merge request is accepted. And in this case, we are going to leave that checked because we're merging a feature branch into the main branch. And feature branches are supposed to be short-lived. They shouldn't be long-lived branches like the main branch and the production branch. So we will leave that checked. For the second option, squash commits when merge request is accepted, this one we will leave unchecked. But squashing commits can be a useful feature. Basically what it means is that, let's say you had 100 commits and maybe there was a large percentage of those commits where you were just fixing small things like adding a semicolon to the end of a statement or adding a comment here and there. It would be useful to reduce the number of commits, and to do that you can squash one, two, or more commits together into a single commit if you wanted to. But I'm going to leave that option unchecked, and I'm going to select Create Merge Request. Okay, so after the merge request gets created, we're brought to this page with three tabs of information: the Overview tab, the Commits tab, and the Changes tab. And in the Overview tab, we have kind of a summary of all of the activities that are happening in the merge request. The Overview tab is really where the conversation about these changes will happen. So we can see the description of the merge request, and in addition to that, we can see other events like where I requested a review from myself, and I also assigned this merge request to myself. We can add comments from this page as well, and we can also control the workflow of the merge request on this tab as well. So from this Overview tab, we can approve the merge request, and we can also proceed with merging the branch into the main branch as well. And the Approve button is available to me because I'm assigned as a reviewer of this merge request, so I can review it I can approve it since I am a reviewer. But you'll notice that next to it says approval is optional. And for the free tier of GitLab, you can't enforce approval before a branch is merged. But if you have a higher tier of GitLab, then you can, there's a setting where you can enforce that one or more approvals have occurred on a merge request before it can be merged. So this merge button would be grayed out if that feature was enabled or if that setting was enabled. And if I scroll up and select the Commits tab, I get a list of all of the commits that are included in this merge request. And then if I select the Changes tab, I can see a diff of the changes that are included in this merge request as well. So in the diff that you see here, we're comparing the main branch with the latest version of the README-introduction branch. If we had made more than one commit on the README-introduction branch, then we could select an older commit and compare an older commit on that branch with the current version of the main branch. It also shows me how many files have changed and how many lines have been added and how many lines have been removed. And in the settings or the preferences here, I can compare changes in line or in a side-by-side view where it will show the main branch version of the README file on one side and the README-introduction branch on the other side. Okay, so we have this side-by-side diff available to us as well. I'm going to select the inline diff. Now, a very useful feature for reviewers and participants of a merge request is the ability to comment on each line of code in a diff. Okay, so if I hover over each line, I have this comment button, and I can add a comment to that line, or I can do, as it says, I can drag for multiple lines. So I can comment on all of these lines from line 3 to line 6. Okay, I can add a new comment for that entire block that we added, or I can add a comment for a single line. Okay, so now I'm going to act as my own reviewer, and I'm going to request some changes to line 6, and I'll ask myself to add an additional activity to the list of activities that I like to do. Okay, and I can either start a review or just add a comment. And since I'm requesting changes, I'm going to select start a review. Okay, and it says submit review, and I'm going to do that. And now that that review has been submitted, I should be able to see it on the, not only in the diff in the changes tab, but I should also be able to see it in the overview tab as part of the activity. So if I scroll down, now I can see that I started a thread on the diff, and I can see the comment that I added here. And since I requested changes, I, as the creator of the merge request, should make those changes, those requested changes, and then when I've done so, I would select resolve thread to indicate to the reviewer that I did make those changes. So I'm going to go ahead and make the changes that were requested on the README file, and I'm going to make the changes locally and not in the editor. And when we make changes locally and we push them after a merge request has already been created for a branch, those changes will be automatically associated with the open merge request for my branch. So let's go ahead and navigate back to the terminal. And I'm going to open the README file in Vim. And in the activities line, I'm going to add one more activity. Okay, so I like mountain biking, tennis, and going to the beach. All right, so I'll go ahead and save and quit, and I'll do a git status, and I'll add the changes to the staging area, and then I'll do a git commit. Well, actually, let me do a git status real quick. Okay, they're in the staging area, and then I'll do a git commit -m, and I'm going to say adding third activity to README, to project README. All right. Okay. So if I do a git status, I have one commit, so I'm ahead of the remote branch, and it says use git push to publish my changes. So I'm going to do that. I'm going to say git push without the -u option because I've already created the readme-introduction branch in GitLab. And you'll notice in the output of the git push command, now it says we get a message from the remote, and it says view merge request for readme-introduction. So it recognizes that we already have a merge request open for this branch, and it specifies which merge request number 1. And then if I navigate back to the GitLab interface, we can see automatically in the merge request gets automatically updated with the latest commit that was pushed to the readme-introduction branch. And in the review that I started on line 6, GitLab recognizes that I modified this line after the review was started. And so it adds kind of like a reply to that thread saying that Moss changed this line in version 2 of the diff just now. Since I made the requested changes, I'm going to go ahead and resolve the thread. So I'll select resolve thread. And now if I switch roles to the reviewer, I would just double check that the changes that I requested were added. So I would select version 2 of the diff, and I would review line 6 to make sure those changes were added, and it looks like they have been. So I would go back to the overview page, and I would select approve, and then I would merge the merge request. So I'm going to go ahead and select merge, and delete source branch is checked. So the readme-introduction branch should be deleted after we select merge. And then GitLab gives us a confirmation to say that the changes were merged successfully and the source branch was deleted. But we do still have the option to cherry pick our change into a new merge request. Or if we found like a regression, for instance, after merging, we can revert the change, which means that it will basically be undoing the merge into the main branch. Okay, so now that we've merged our first merge request, let's navigate back to the home page. And we're checked out to the main branch. And if I scroll down to review the README file, we can see that now on the main branch, the changes that were previously on the readme-introduction branch are now included on the main branch's version of the file. But remember that since we're using the environment branches variation of the GitLab flow, when we merge into the main branch acts as kind of like a pre-production branch or maybe a staging environment. So our final destination, or the final target branch, is the production branch. So we need to make a second merge request to merge the main branch now into the production branch. So to create that second merge request, I'm going to navigate to the merge requests section, and I'm going to select new merge request. And on this page, I have to select the source branch and then the target branch. Okay, our target branch is listed as main right now, but we know that's not the case. Our target branch should be the production branch, and our source branch should be the main branch. So here we're saying we want to merge main into the production branch. Okay, so I'm going to select compare branches and continue. And for the title, I'll provide something similar to the original commit message. I'll just say that we updated the README file with an introduction. I'll leave the description blank, and then I will assign it to myself, and I will also assign myself as a reviewer. Okay, and then I will select create merge request. And for this merge request, I'm just going to directly approve and merge it. But it is important to note that for every merge request that we create between two branches, that when a merge request is opened, it should trigger automated testing. And as changes are promoted up through pre-production branches and they get closer to being merged into the production branch, the scope of testing broadens at each level. So when we have a merge request open from the feature branch into the main branch, our scope of testing will likely be smaller than when we're merging the main branch into the production branch. So we'll go ahead and assume that automated testing was completed when this merge request was opened, and I'm going to select approve, and then I'm going to select merge. And merging these changes into the production branch essentially means that we are cutting a release. And to formalize that release, what we can do is create a Git tag. So I'm going to navigate to the repository section, and then I'm going to go to tags. And currently we don't have any tags in this repository, and I'm going to select new tag to create one. And I'm going to use semantic versioning, and I'm just going to say v1.0 for the tag name. And then we are going to create the tag not from the main branch, but from the production branch, since it represents our production environment. And the tag can optionally have a message associated with it. I'm just going to say this is the first release. And under the release notes, I'll simply say updated the project README with introduction section. Okay. And then I will select create tag. And now that we've created this tag, it should have also generated a release in the deployments section. So if I navigate to deployments and then releases, we will see version 1.0, and it gives us the ability to download assets of the source code. Okay, so now we've completed the GitLab flow, but there is one last step that we need to do, and that is to sync our local repository with the remote repository. Right now, the remote repository has commits that the local repository on my machine doesn't have. So we need to do a git pull from the command line to sync the remote repository with our local repository. So I'll navigate to the terminal, and in my project, I'm going to first do a git status. And when I do a git status, you'll notice that I'm currently checked out to the readme-introduction branch. And that branch no longer exists in the remote repository. It was deleted after we merged the branch into the main branch. So what I'll want to do here is first do a git checkout to the main branch. And now that I'm checked out to the main branch, I'm going to do a git pull. Okay, and so the git pull worked successfully. You'll notice that it also recognized that there was a new tag, so it created a new tag in my local repository. But if I were to execute the git branch command here, you'll see that the main branch exists, but also the readme-introduction branch still exists locally. So we need to delete the local version of that branch. And to do so, we can say git branch -d readme-introduction, and that deleted the local version of the readme branch. Now that command deleted the local version of the branch, but my local repository still thinks that there is a remote branch called readme-introduction. So if I do git branch --all, it'll show me not only the local branches, but also the remote branches. And the remote branches are listed in red, and you see here that the readme-introduction branch is still listed. And to update this list of remote branches, we can pass in an option to the git pull command called --prune, and this will prune remote branches from this list. So I'm going to hit enter here, and in the output it says that it deleted the readme-introduction branch, and I'll run the git branch command again, And we can see it's no longer listed in the local branches or in the remote branches list anymore. And there is one last thing that we should do that I forgot about before wrapping up the GitLab flow, and that is to close out the original issue that we created in the GitLab project. Now that we've synced the local repository with the remote repository, let's go ahead and close out that issue. So I'm going to navigate back to GitLab, and then I'll navigate to the issues section and then list. And then I'll select the issue that I created. And then I'm going to indicate in the checkbox that we completed this subtask, which updates the count of tasks completed. And once we've done that, we can go ahead and close this issue. So I'm going to select close issue. In addition to closing the issue, I'm also going to mark it as done. And now that we've closed the issue that we created for this change to the README file, we've come full circle with the GitLab flow. So congratulations on completing your first round of the GitLab flow, and in the next video we are going to explore the CI/CD features of GitLab. We have familiarized ourselves with the GitLab interface and are now comfortable using the GitLab flow, but we're still not using some of the most important features the GitLab platform offers. In today's world, just about every codebase is supported by a continuous integration and continuous delivery/deployment pipeline. Let's take a look at the features related to CI/CD that GitLab offers for its projects. In this video, I'm going to show you how to perform CI/CD in GitLab. Let's define some important GitLab CI/CD terminology. The first is a GitLab pipeline. A pipeline is a top-level component used to define a CI/CD process for a GitLab project. And within a pipeline, we can define stages and jobs. Next, we have jobs. Jobs are associated with stages within a pipeline, and they define the actual steps to be executed, such as running commands to compile code. Then we have stages. Pipeline stages define the chronological order of jobs. And finally, we have GitLab runners. GitLab Runner is an open source application that executes the instructions defined within jobs. It's a program that can be installed on your local machine, a cloud server, or on-prem. Shared runners are hosted by GitLab. Now that we've defined these concepts, let's get started. Okay, so the first thing that I want to do is quickly walk through the code base that we're going to be using. I've created this GitLab project called Sample Maven Project, and it's a very simple Maven code base, and it's actually based off of a code base that you can automatically generate from a tutorial by Maven. And if you simply search Maven in 5 minutes in your browser, the first link here, Maven in 5 minutes, has a tutorial where you can generate the same project. So under this section, creating a project, I generated this code base using this command. So it creates a project of Maven archetype quick start. So let's take a look at that code base in GitLab. If I exit out of the tutorial, and then in the root directory of the GitLab project, I'll go into source. So we have a POM file, and then we have the source directory. And in the source directory, we have it separated out by the test directory, and then the main directory, which contains a single class called app. And inside of the app class, it simply prints out hello world to the console. And then if I go back to the test directory, we have a single test class called app test. And if I open that up, we have a JUnit test class, and then a single test case within that test class. In this test case asserts true on a condition that is always true. So this test case will always pass unless we were to change this condition to false. And that's pretty much all there is to this code base. It's very straightforward. So let's navigate back to the project homepage. So to define a CI/CD pipeline for a GitLab project, you need to create a YAML file at the root directory of your project, and its name should be .gitlab-ci.yaml. And there's two ways that you can create that file. You can either create it from the drop down here, so you could just create a new file and call it .gitlab-ci.yaml, or you can create it from the CICD section, and they have a dedicated section for editing and creating GitLab pipelines. I think that the best method for creating pipelines is using the pipeline editor, and I'll show you why. So I'm going to select editor. So this will create a pipeline on the main branch, and it says create a new .gitlab-ci.yaml file at the root of the repository to get started. And then I can create a new CI/CD pipeline by clicking this button. So I'm going to select it. And on the right-hand side, we have this help section for getting started with GitLab CI/CD. I'm going to close this out, but before I do, I'm going to open up this link for viewing its syntax reference document that GitLab provides. I'm just going to open that up in a new tab because we may refer to it later on. Okay, and after I've opened that up, I'm going to go ahead and collapse that help section. And when we open the editor for the first time, GitLab automatically fills out this template pipeline definition for a very basic pipeline. And in the pipeline definition, there's 3 stages defined. So here's a stages statement. And then under that statement, we have a build stage, a test stage, and then a deploy stage. And this isn't the only pipeline template that GitLab offers. You can see up here it says browse templates. But if I were to open the pipeline section up in a new tab, if I scroll down, you can see a list of CI/CD templates based on your technology stack or the framework that you're using. And there is a template for just about every technology that you can think of. You have Golang templates, Flutter templates, Gradle. There's even a Maven template for Maven projects, but we aren't going to use this template. And we also are not going to use the template defined here as well. But the pipeline definition that we'll write is going to be from scratch, and it will closely match this structure where we have a build, test, and deploy stage. And under the stages definition, they define the jobs. And the first job here is the build job. And you don't necessarily have to follow this naming convention. You could just call this build if you wanted to, but it does make it clear when you add the hyphen job to the statement. And then to associate a job with a particular stage, we would just use the stage keyword here. And then the value would be the name of the stage that we want this job associated with. And after associating the job with a particular stage, we can then specify a shell script that would be executed by the GitLab runner. So if I hover over any of these keywords, it gives me a definition of the keyword. And you can see here for the script, it says these would be shell scripts executed by the GitLab runner. And it is the only required property of jobs. So under the script statement, they have 2 echo statements where they're kind of, pretending to compile a code base, right? And then under the build job, they've defined a unit test job, which is associated with the test stage, where they run unit tests, and then a lint test job that is also associated with the test stage. So there are 2 jobs associated with the test stage. And then the last job is the deploy job, which is associated with the deploy stage. Now, one thing I want you to notice about using the pipeline editor is at the top, it says this GitLab CI configuration is valid. So when we use the editor, one of the benefits of using the editor is that GitLab, while we're editing the pipeline, GitLab is checking and validating the pipeline syntax and the configuration to make sure that it is actually going to run. In addition, we also get these tabs here, the Visualize, Lint, and View Merged YAML tabs. If we look at the Visualize tab, it gives us a graphical version of our pipeline. So now you can see that the build job is associated with the build stage. The test jobs, the unit tests and the lint test jobs are associated with the test stage, and the deploy job is associated with the deploy stage. By default, when multiple jobs are associated with a single stage, those jobs will be executed in parallel. And then on the lint tab, it gives us some information on the parameters and properties of our pipeline definition. So here it also says that the syntax is correct and the configuration is valid. And then for each of the parameters in the pipeline, it gives us some properties associated with that parameter. So you can see here all of the jobs are listed. And then in the value, we have these properties also listed under the value. So for this first property, we have the only policy, and its value is branches and tags. And this policy is referring to the only keyword that you can use in a pipeline definition. So if we take a look at the keyword reference, we have only and except keywords, and you can use only and except with 4 other keywords: references, like Git references, pipeline variables, changes, and also Kubernetes. And these keywords control if a job will run in a pipeline, because if I use references, for instance, I can specify specific Git references. So only run this job when the Git reference matches a particular regular expression. So for instance, only run this job if it's a particular branch, like the main branch or a feature branch, and that can be a regular expression as well. So it can be like any branch that starts with a Jira issue ID, for instance. So going back to that pipeline definition, if we take a look at the value here, branches and tags, this job will run when the Git reference for the pipeline is a Git branch or a Git tag. And then below the only policy, we have the when keyword, and its value is on success. And this specifies a conditional. The when keyword specifies a conditional. So when should you run this job? Only on success of previous stages. So this is only going to run if prior stages have passed successfully. Otherwise, if a earlier stage has failed, this job will not run. And this is the default value for this condition. So we didn't have to explicitly set the only keyword or the when keyword in that pipeline definition, because this is the default behavior. Jobs will only run when prior jobs have passed successfully, unless you change that, you explicitly change that condition. Okay, and then on the last tab, we can view the merged YAML file. Okay, so this is just a view-only version of the YAML file without the comments. And then I'm going to navigate back to the Edit tab. Okay, so let's start editing this template so that it works for our Maven project. So I'm going to delete all of these comments here. And like I said before, our pipeline definition is going to be similar to this one. So I am going to keep the stages definition, and I also will keep these jobs, but I'm going to clean it up a little bit. So I'm going to delete the extra echo statement. We'll keep that lint test job, and then we'll keep the unit test job as well. So now we can start adding our own stuff to this pipeline definition. And the first thing that I want to specify is the Docker image that the GitLab runners should use when they execute jobs in this pipeline. So if your project has dependencies that need to be installed for it to be able to compile the code base and run tests on the code base, you can specify a Docker image that includes those dependencies, and the GitLab runner will use that image to actually execute all of the steps defined within your jobs. And to specify the image, it's very simple. At the top here, I'm going to use the image keyword. And then after specifying the image keyword, we would provide a value. And that value is going to be the name of the Docker image that we want the runner to use. And in this case, we're going to use the Maven image, which includes all of the dependencies that we're going to need in order to compile and test and run our Maven project. So after specifying the Maven image name, I'm going to specify the version, and in this case, I'm just going to say latest. So I'm going to use the latest Docker image for Maven. So now that we've defined the Docker image that should be used when running these jobs, the next thing that I want to define are variables. So we can define pipeline variables inside of our pipeline definition using the variables keyword. And what should be our variables for this pipeline definition? Well, we're going to have two variables. The first is going to be called Maven CLI options. And the only option that we're going to pass to Maven is the -- batch mode. And this will run Maven in a non-interactive mode so that it won't prompt the user for input. And now that I've defined this variable, I can reference it in any of the shell scripts that I define in any job in the pipeline definition. And I said that there were two variables, and the second variable is going to be called Maven options. Okay. And we're only going to pass in one option, and that's the location of the local repo. So I'm going to say -d-maven.repo.local is equal to, and then I'm actually going to reference an environment variable that is known as a predefined environment variable. And it's called CI_project directory. So we don't have to explicitly define the value of this environment variable because it's predefined by GitLab. Okay, so within the project directory, we will specify the .m2 folder and then repository. And I think the GitLab configuration validator is complaining about a couple of things that I've done here. If I hover over the yellow squiggly line, it says cannot read an implicit mapping pair. I think the first thing is this extra quotation mark, but also I've used tabs here, and I think I should be using 2 spaces. So I'm going to do 1, 2, and 1, 2. So now that we've defined those variables, the next thing I want to do is utilize GitLab's built-in caching feature for its pipelines. We can actually cache artifacts of a pipeline run to speed up future runs of the pipeline. And to do that, we simply need to specify the cache keyword. And then after using the cache keyword, we would then specify the paths within the project that we would like to cache. And in our case, it's really important to cache the Maven dependencies because otherwise the Maven dependencies will be re-downloaded for each job that runs. So below the paths keyword, we can specify the path that we want to cache, which is going to be .m2 and then repository. Okay, so now that we're caching the Maven dependencies, we can move on to the build job. And under the build job, I'm going to leave this echo statement, but I'm going to add one more shell script. And here I'm going to invoke Maven with the CLI options. So I'm going to reference the variable that we defined. So Maven CLI options, and then we will use the compile command. And that's all we need for the build job. So I'll scroll down to the unit test job. And again, I'm going to add one more shell statement. And this is going to be Maven. And then we will use the Maven CLI options again. And then we'll invoke the test command. Now, one thing that is really cool is that GitLab can actually render JUnit test reports. And all we have to do is generate those test reports as artifacts. So under the script statements, I'm going to specify the artifacts keyword. When we use the artifacts keyword, we can specify a path that contains artifacts that we would like to persist beyond the length of the job. So after the pipeline has finished, any paths that were specified as containing artifacts, those items will be persisted after the pipeline finishes. So we can access those artifacts and download them from GitLab. And in this case, we're storing JUnit reports. So the first thing that I want to specify is when these artifacts should be generated. And I'm going to say that they should always be generated. And then under the when condition, I'm going to specify the reports keyword. And under reports, I'm going to specify JUnit. Okay. And under the JUnit keyword, we can specify the path to our JUnit reports. And that's going to be under the target directory, Surefire, reports, test, and then any file with test-.xml. Okay. I'll also do this for the failsafe reports. So I'm going to do this. Okay. So now that we're generating those JUnit reports as artifacts, we should be able to download those reports after the pipeline finishes. And then also we will be able to, those reports will be rendered within the GitLab UI. So you'll be able to see what that looks like once we run this pipeline. Okay, so after the unit test job, there is the lint test job, and it's not doing anything, but I am going to leave this job there so that you can kind of see that the job runs in parallel. And then after the lint test job, we have the deploy job. For the deploy job, we won't actually deploy the application to some remote server. What we'll do is we'll just use Maven package, and then we'll run the application locally. So under the echo statement, what we're going to do is invoke Maven, and we will invoke it with our CLI options. And we're going to invoke the package command. And finally, after invoking package, we will run the program using Maven, and then we'll reference the CLI options, and then we'll say exec java-d exec.main is equal to com.mycompany.app, and then the app class. So when this command is ran, we should see hello world printed out to the console of the job. Now, the last thing that I want to add to the deploy job is the environment keyword. So we're going to add an environment to the deploy job, and it will be the staging environment. So this deploy job is going to, quote unquote, deploy our Maven application to the staging environment. And what that is going to do is it's going to create a deployment under the deployment section in the environments page. So we'll take a look at that after the pipeline has ran. Other than that, I think that's pretty much everything that we need for this pipeline. So all we need to do is commit our changes to the file. And as soon as we make a new commit, the pipeline will run. So I'm going to select commit changes. And it says that it's currently checking the pipeline status. And in a little bit, it should show up with a link to the running pipeline. And there we have the link to the running pipeline. So I'm going to go ahead and select that and open it up in a new tab. So when we navigate to the pipeline tab, we can see the status of each job in each stage. And you can see under the testing stage that both test jobs are currently running in parallel. And the build job has already completed successfully. So now the deploy job has begun, now that both of the test jobs have completed successfully. And this pipeline run should take a little bit longer because on the first run, the cache is empty. So we haven't cached any of the Maven dependencies. So after this run, the pipeline run should be a lot quicker. And now it looks like the deploy job has completed successfully. So the whole pipeline has completed successfully. Let's take a look at each one of these jobs. So I'm going to open up the build job in a new link. And when we open up a job, we get the console output of all of the commands that we defined in the job definition. So up at the top, we can see that the job begins. It's running with GitLab runner. And then after that, you can see that the GitLab runner is pulling the Maven, the latest Maven Docker image, so that it can run the job within that Docker image. And it's really convenient. Next to each of these statements, you get the time duration for how long that particular command took. And in the top right, you can also see the total duration of the job, which was 44 seconds. The timeout period is set to 1 hour, and that simply means that if at 1 hour the job is still running, that the job will automatically be canceled because maybe it's the job is hanging for some unknown reason, and you don't want to utilize all of your runner resources on a job that's hanging. So if we scroll down further in the console, we can see that the runner clones down the code base, and then on line 30 it checks the cache for default, and it says fatal file does not exist. So there is no cache because this is the first run of the pipeline. And then on line 36 we can see the first shell statement of our build job where we say we're compiling the code. We invoke Maven compile with the CLI options. And then starting at line 44, you can see where Maven begins downloading all of the Maven dependencies. So what I'm going to do is I'm going to scroll down below where it's downloading those dependencies. And after it downloads the dependencies, it compiles a module, and we can see that it was a successful build, and it took a total of 8 seconds. And since the job was successful, you can see at line 393, it's saving a new cache. And on 395, we can see that it caches the .m2 repository directory, and then it uploads that zip file to essentially back to GitLab. So now that we've seen the build job, let's take a look at the test job, not the lint test job, but the unit test job. So I'll open that in a new tab. And here, if I scroll up to the top, I'm going to use this button to scroll to the top. We can see roughly the same output as we did in the build job, where it's preparing the Maven Docker image to execute our Maven commands on. So starting on line 36, we can see where our unit test job begins, and then we invoke Maven with our CLI options and then the test command. Okay, and then it downloads the necessary dependencies. And then if I scroll down below that, we can see where the tests actually get executed, and 1 test ran and there were 0 failures. So we get a successful build, and then below that you can see here it saves the cache for the successful job, and we can see that it's caching the .m2 repository directory. Now below the cache creation, starting at line 211, you can see where it's uploading the artifacts that we created. And the artifacts that we generated, remember in the pipeline definition, were the JUnit test reports. And it identifies the Surefire reports directory on line 211. There were no fail-safe reports, so it says that there were no matching files there. But it did find 1 matching file for the Surefire test reports, and it uploaded those artifacts as a JUnit test report. So we'll take a look at those test reports in a little bit, but first I'm going to go back to the pipeline. And let's open up the deploy job. And let's quickly walk through the deploy job as well. So I'm going to scroll up using the scroll to top button. And then again, we have a very similar output as we did in the previous jobs. It clones down the code base. It recognizes that there is a cache, and it downloads that cache and it extracts it. And then the Maven package command is invoked. So it then downloads the necessary dependencies, and if I scroll down, you can see it's running the tests again. And then if I scroll further, it packages the program as a jar file, and then it runs the exec command on the main class. Okay, and then it downloads more dependencies, and then if I scroll down to the bottom, you can see where on line 250 it actually runs the app class, and it prints to the console hello world. And then finally on line 258, you can see that it creates a new cache. Okay, and then the job finishes. So now that we've looked at the job output, let's navigate back to the pipeline tab. And on the pipeline tab, we can see several tabs here: the pipeline, the overall graphical view of the pipeline, but then we also have this test tab, and we can see that there is one test. So if I open this test tab, we can get a summary of the tests that pass, and this is generated from the JUnit reports, and it shows us which jobs are associated with those tests. And if I wanted to download these test reports, I could simply go back to the pipelines page, which will show me a list of all of the pipelines that have ran. And you can see the pipeline that we just ran over here on the right. It shows me an artifacts dropdown, and I can actually download artifacts that were generated by the pipeline. And in this case, there was only one set of artifacts, which was the JUnit test reports. And in addition to the artifacts, I also specified an environment in the deploy job, and that should have showed up under the deployments. So if I go to deployments and then environments, we can see that there is one environment, the staging environment, and there is one deployment to the staging environment, and it shows the job associated with that deployment and the commit as well. If I wanted to see a list of all of the jobs that have ran, I can go back to the CICD section and select jobs, and this will show me a list of all of the jobs that have ran in the past. You'll also notice that under the jobs section, we can create schedules for our pipeline. So if I select new schedule, I can specify an interval pattern or a cron pattern to run our pipeline, maybe like every day or every week. So that's also a useful feature that we can use for our GitLab pipelines. Now, a few more things that I'd like to show you are in the settings. So if I go to settings and then CICD, we can update various settings related to our pipeline. So if I expand the general pipeline configuration, I can actually specify a custom path for the pipeline definition within the project. I can also change the timeout period for jobs that fail if they run longer than the timeout period. And then below the general settings, if I collapse this, you have auto DevOps, and if you turn this on, GitLab will attempt to automatically set up a pipeline based off of your project's technology, like whether it's a Maven project or a Golang project or something like that. Under auto DevOps, we can configure GitLab runners, and right now I've been using shared runners, which are hosted by GitLab. And under shared runners, I can see all of the runners that are available to me that I can use. However, if I didn't want to use shared runners and instead I wanted to host the GitLab runner program on my own infrastructure, I could register my own runners with this GitLab project so that in the pipeline definition, I can assign jobs to those runners that are hosted on my infrastructure. And then under the runners configuration, we can also define pipeline variables at the project level here as well. So if I expand the variables section out, I can create new variables, and these variables that I create can be protected and masked. So protected variables can only be exposed to protected branches or tags, and then masked variables are hidden in job logs. And this is useful in the event that you have environment variables that would be passwords. So for instance, if you're trying to upload an artifact to Artifactory and you need to authenticate with your Artifactory instance, you would need the username and password for the Artifactory user. In that case, you can use a masked variable for the Artifactory password. So if I were to select add variable, I can specify the key of the variable like Artifactory password, and then the value of the password. And I can specify the type and the environment scope, and I can protect it. And then I can also mask the variable as well. If I added that variable, you can see that the value here is not visible. But if I need to, I can still reveal the value using this button. And the last thing that I'd like to mention are pipeline triggers. So you can trigger a pipeline for a branch or a tag by using a trigger token. So a use case, a sample use case for this might be if you wanted to trigger a pipeline to run via a Slack command. So if you had a Slack bot, you can provide the token to the Slack bot so that the Slack bot can communicate with the GitLab API and trigger this pipeline to run. So I'm going to navigate back to the CICD pipeline section. And I think that wraps up everything that I wanted to cover in this particular module. So I hope you enjoyed this video.